Hello and welcome to another brand new sparkling episode of Lexx Education. The crowd goes wild. The science podcast where me, comedian Laura Lexx, tries to learn science from my real-life brother Ron.
Hello, it's me, Brother Ron.
It is Brother Ron, the king of backing out of catchphrases. How are you doing this week, Ron?
I'm good. I'm on holiday in Vienna. I've read 100 pages of my book in like 3 days. I've eaten lots of Käsekreiner. I've eaten lots of Leberkäse. I've discovered something called Käferbohnen, which are the most delicious beans you've ever eaten in your life.
I want some of these beans.
They're it's like a specific way of preparing them, but it's done with like pumpkin oil and apple cider vinegar, and it's
That sounds good.
real good.
I went to a safari park type zoo type thing yesterday and saw lots of really good animals and rode on a lot of rides. I rode on a ride, Ron, which I think has the best pun name I've ever been on. So,
I
don't think you'll guess it.
No, tell me.
So the ride, right? It's one of those ones where you're on a flat surface and you kind of go round in a circle, you know, and then like, whoa, round in a circle.
Oh, yeah, I know those guys. And they always have like a airbrush picture of Michael Jackson behind it or something.
Well, not this time, Ron, because the thing we were in was a bus, right? But shaped like a hippopotamus. A hippopotamus! A hippopotamus! I rode a hippopotamus.
That's good. I like that because it's not like these things are always buses. And it's a theme on that. They've had to go 2 steps and they've had to make it a bus and then make it a hippopotamus.
Yeah. It was very good. It was a lot of fun. I had a very good time. And I saw my favourite animal the whole way round was the colobus monkey.
Which ones are those guys?
They're like a black and white type, dude. And there was a young one, which when we went round the first time was...
Oh, they've got like cowboy
tassels.
fringes on their sleeves.
Yeah, which looks a lot like a dress that I own and wear. And I was delighted that, you know, sometimes you see those tweet threads that's like, Sarah Millican has teapots, etc., etc. I'm like, man, I might make it my life's mission now to buy dresses that are sort of like monkeys in the hope that someone will do a thread of Laura Lexx's monkeys.
They've got kind of a demure sort of Moira Rose vibe to them.
Oh, they're wonderful. And when we first went round, the sort of child one was playing with its mum, and they were like really faux wrestling. Like this kid was like, I'm going to get you. And then the mum would just stick one arm out and be like, yeah, okay, kid, no. And then when we went back round in the evening, they were all just lying down together and the little one was nursing and they were sitting like a little family, and it was so beautiful, Ron. I loved them. Also, I rode a sloth on a carousel, and it was very hard to get down.
Don't say the thing about your butthole.
Oh, it was so hot. That's a colobus
So you
monkey.
did 2 tweets about it. Oh, that is sweet.
I did 1 tweet because there was a typo in the first one, so I deleted it.
Oh, I saw it twice. Okay.
Oh, thanks for liking it neither time.
Didn't like it that much.
You're not a very nice boy. Anyway, right, today's episode, we've got some thank yous to do. That's Animal Catch-Up. Thank you to Podspike. Hello, Podspike, Dan and Suji at Podspike are the wonderfulest people. You might have found us through one of our little infographic trailer clip things that I studiously put out all the time. Dan and Suji helped us make those. So our illustrations were done by Matthew Grant from The Noise Next Door. Check them out. Wonderful comedy geniuses. But then Dan and Suji turned them into templates that we could use to attract your attention and make you listen to our nonsense. So if you want some help in marketing your podcast, then please turn to Podspike.
They also got us into Pod Bible and most recently, The Guardian.
Yes, we're a Guardian podcast now.
Buy us at Waitrose.
My bum is calamari.
You can't take a confident sip after saying that. Like, I'm going to yes and some banter out of calamari arseholes.
You should. Get on the hippopotamus. We have a new review on the Apple. Thank you very much for our first stateside review, Dave. You legend.
Yeah, howdy, Dave.
Hi, Dave. Thanks for giving us a 5-star review. And the title is just Laura is a star, brackets fuck Ron. Those brackets that I've added. And Dave says, great idea to mix comedy with science. We need Laura to visit the States. Oh, can you imagine, Ron, if we did a live version of this podcast, but just not even bothered with the UK, just went straight to America.
And not even bothered with the science, apparently.
Yeah!
Just you having a Netflix special.
Ooh. Let's move to LA, Ron. Let's become LA kids.
Oh, God, that sounds awful.
Yeah, so I think we would be
too
on
hot.
Prozac within
We're
a
too
day.
fat and ugly. We would not get on.
Hey, I'm well up for lip fillers, though. Let's do it. On social media this week, we've been discussing nicknames for your listenership as a whole. What do you want to be called? Listeners are so boring. Fans feels up our own calamari rings. So suggestions so far from people have been Lab Rats, the Swamp Brains, Lexplorers, Lexperts. What do you think the coalition of peeps should be called?
Yeah, I want to give a special shout out to Overdusky for Lextracurricular as one of the puns. That was great.
I think if we do ever get around to doing anything on Patreon, Lextracurricular will be the name of the extra podcast or whatever we end up doing.
Yeah.
Yeah, there's also been quite a lot of requests for merch this week, which I'm not sure if we're quite there with a big enough listenership for merch. But hey, when we are, don't worry about it. We've definitely got some catchphrases now. Jeff is playing episode catch-up. Jeff wants to know if we want to do a down survivors group for people that survived listening to that episode. I don't know if we can advertise that after like 7 episodes of our podcast, people wanted a survivors group made. Yeah. Is that good marketing? Hey, Podspike, let us know. We've had another experiment suggestion. What was this one about, Ron?
Just burning a flake, really. I was in a museum. I was in a museum called the Albertina, and in a Picasso and Monet exhibition, just sat in the corner watching Kay burn a flake. And the weirdest part is that so the reason why it was of interest is that the flake didn't melt; it just set fire. That never occurred to me while I was watching it. I was just like, oh, why are they doing this?
So we'll put that on the list, though. It's on the list of experiments to be done. Now, we're going back a few weeks here with this last thing that someone mentioned this week. John on Twitter is also playing episode catch-up. I don't know if you remember, quite early doors, we discussed Ron's neighbour leaving a poo in a bag in a communal hallway, a dog poo. And
I hope there's no confirmation.
Well, that's true, actually. John said, and it blew my mind, he said, why would you bag it if it happened in a flat? Why wouldn't you just flush it? And it's honestly the first time in 2 years of having a dog and collecting up her poops from the garden and bagging them and binning them that it's ever occurred to me to just flush them.
Have you started flushing them now?
Yes.
Oh, you must be saving on bags on bags.
Yeah. So thank you, John. You've blown my world right open. I can flush dog poops.
Just the same as the rest of them.
Yeah. So you guys have really had a busy week. Thank you very much. We'll jump into the episode now. This week we're back to physics. Woof. It is, it's like energy constants. That's what we're doing this week.
Energy transfers.
Yeah. Ugh. Have a good time. Hello, Ron.
Hello.
It's Physics Day.
It is Physics Day. For the listener, I was just telling Laura that I made a boo-boo in the horrible physics lesson that we did last time. We did that slightly out of order. So for probably music to Laura's ears, we are doing a different topic inside physics today.
What? Oh, physics. Oh, it was all that ball rolling last time, wasn't it? Jesus, that annoyed me so much. Do you know what annoyed me mainly about that? Is I got out of that episode and I went downstairs and I was like, oh, Tom, you'll never guess what Ron's trying to pretend is real. And then I explained it to Tom and he just went, yeah, that sounds about right. I was like, ugh, shut up.
Yeah, because it is right.
It's not, though. Is it? Like, logically. I understand that it's probably right, theoretically, but it isn't right logically. Do you know what I mean?
No.
Like, an ant isn't bound... Anyway. Anyway, I'm not getting back into this. If we're not doing it, we're not doing it. Brilliant. I'm glad they've cut it from the syllabus based
No, it
on the
will
last
come back.
episode.
It will come back and we will revisit it. We may just do that lesson again.
All
But
right,
no,
I'm
today-
going to come in with a zen open mind towards physics.
So what I've done today, because we're talking about systems again, I've translated it all into stuff that you know and like.
Great. The While You Were Sleeping Guide to Physics.
Exactly. So we're talking about energy transfers within a system. Okay.
Okay.
The first thing it wants us to know is that we can calculate energy changes when a temperature changes and how much energy it takes to change the temperature of something. So we have an equation for that.
It just instantly makes me want to get up and walk around the room and do something else.
Thanks.
Not you. You're a nice boy. It's just sad, isn't it?
So we have an equation.
Mm-hmm.
Delta E equals MC delta theta.
Delta E equals MC delta theta.
Theta, yeah. So do you know what delta means in this context?
No.
Do you know
I
how to
haven't
draw?
even got the energy to make up a funny thing about it either.
Do you know what? Do you know how to draw delta?
No.
What have you written down there? What notes were you just making? Did you just scribble on the page and pretend?
No. I wrote DE equals McDeath.
What?
Delta Echo. What did you say? Delta
No,
E.
because that's a fucking D. That's not a delta.
Yeah, it's a D for delta. D for delta. E equals MC delta theta.
No, so right. A delta is a triangle. It's the fourth letter of
Say triangle then.
No, it's the fourth letter of the Greek alphabet.
Ugh. Am I Greek? Triangle.
Triangle, capital E. When we were talking about energy, it's always a capital E of E equals MC squared, fame.
Yeah.
M, just a little m.
Well, you just said it was always a capital.
No, I didn't. I said it's always a capital E when we're talking about energy.
Why wouldn't you formalise that across all the letters?
Because capital M and little m mean different things.
Jesus Christ. I hate it, Ron. I'm so angry. We've only been recording for like 2 minutes. You and I just had an hour-long meeting and it was lovely. And just chatting nicely. And then you start telling me about this and I want to squash your little head against a wall until you stop talking to me. Alyssa
I've
Lamb.
started, so I'll finish. A little C.
Yeah.
And then another triangle for delta.
Yeah.
And then theta looks like a 0 with a line through it.
Great. What's this, a fucking art class? Cool. That makes as much sense to me as what I'd written down. D equals McDeath.
Yes, but it's like fucking right now, so now we can move on. The delta is the fourth letter of the Greek alphabet. Great. In this context, when it's a capital delta, which is what the triangle is...
You can hear what you're saying, right? It's so stupid. Capital delta is different to the tiny delta.
Yeah, like all letters. It's just a letter in a different language.
No, but a capital M is the same as a baby M. You're not like M or They're the same.
Yes, but in formulas they mean different things.
Why don't you just make different shapes then?
They have! They're called letters. They're all different. The E looks different to the C, which looks different to a delta.
Yeah, but why have a capital M and a small m? Have an M and then draw like a big circle with a small circle in the middle and spikes coming out the side.
Right, okay, so Laura, are you saying that if I was sat here today teaching you this and it was actually bongo E equals MC bongo theta, you'd be like, oh, great job, bongo. I'm happy learning about this shape.
Yeah.
Are you actually saying that?
Well, I just don't think I should... No, I'd still be having a horrible time because it's horrible and stupid. I just don't think you should be laughing at me for writing down DE. If someone says to me delta ebim or whatever it was you said, how the hell do I know that delta is a triangle?
Delta ebin?
What was the E for?
Energy.
It's just an E then.
It's a capital E for energy.
Right, cool. So triangle energy equals...
MC triangle theta.
Yeah.
Okay. Delta, in this context, means change. Like, so when you say delta E, that means change in energy. Energy change. Okay? How much is the energy changing by?
Okay.
M stands for the mass of the thing that we're heating or cooling. C is something called the specific heat constant. That basically just means how much energy does it take to heat that thing as a constant. And then we've got delta theta. That is the change in temperature. Okay?
If you say so, my boy.
So, get your calculator out. We're going to calculate the amount of energy it takes for you to make 2 cups of tea.
Oh, I'd love a cup of tea.
Yeah, see? You love tea.
Yeah, but it just happens. I've had loads of tea without knowing how to do the energy for it.
So...
Why did I pick my phone up? I'm on Twitter. What did I do?
You need your calculator.
Oh, calculator. Oh, another shitty email. I just pull out of a gig for somebody. And they're like, are you even going to offer to help replace yourself? I'm like, no. For the same reason that if you had to pull the gig, you wouldn't then scurry around finding me a different gig for that Friday night. Like, we just have different jobs, mate. That one isn't mine.
When I call in sick to work, I don't go, my mate Noah's going to step in and
Exactly.
answer emails
It's
for
like,
me.
and I get it. Like, it's not great to pull out on somebody's, gig, but you've got a couple of weeks to replace me, and I've said sorry, and there's nothing I can do about it.
Yeah,
Anywho,
baffling.
I've got a calculator now.
Okay, cool. So, we're going to boil enough water for 2 cups of tea.
It would be quite funny to send Noah to your job, though. Ron's got a friend called Noah who he's so delightfully, brilliantly, crazily intelligent and then dopey. He's excellent. I reckon he would do your job for a day. He's the sort of person, if you just phoned him and went, Noah, can you just go to work for me today? He'd be like, yeah, okay, boop, boop, ba-doo. And everyone would love him.
Yeah.
He used to live with orangutans.
He did.
Anyway.
He said it was like studying the deck chairs on the Titanic.
Oh.
Yikes!
Let's not talk about that. I'm sad enough about climate change this week.
Yeah. Anywho, right, so we are heating enough water for 2 cups of tea. Okay?
Great.
So the average mug is 330 ml. So we're going to call that 330 grams. Okay?
Sure.
The water is starting at room temperature, 21 Write this down.
You said to get my calculator out. I'm holding my calculator.
Write this down.
Oh my God. What am I writing? I've got a mug, 2 mugs.
2 mugs worth of water, 330 millilitres, which for today we're just going to say is 330 grams.
330 grams times 2 of water.
Yep.
Yeah.
The water is at room temperature when we start, so 21 degrees.
Okay. At start. Yep.
And the specific heat constant of water is 4,185.5.
4,185.5 is the heat constant of water.
How much energy does it take to boil that water?
I fucking don't know, and I don't care.
Shut up! Shut up and do it! Work it out.
Why does it make me so angry? It makes me physically want to be mean to you. That you're trying to make me understand this. The other subjects don't do this. Ugh. I love that this podcast is accidentally going to develop 3 quite separate strains of episodes where it's like, oh, we might actually learn something in biology. Oh, in chemistry, they'll have a nice chat about the world. And then in physics, it's just 2 furiously frustrated people trying to get through 45 minutes.
But, and I've said this before, if we don't get through it, there is going to be just a string of physics episodes once we're finished with the other 2.
All right, so... is that all the information I get?
That's all the information you need.
I don't know if it is.
Right,
So,
okay, so let's...
hang on, let me think. So the triangle... What was the triangle?
The triangle means change. It means, so we are working out delta E, so we don't need to worry about that for now. We just need to worry about the MC delta theta, okay?
Yeah.
So I've given you the C. The C is the specific heat constant, right?
Yeah. So
So now
the
we
M
need
is the mass. So
so how much mass have we got?
660.
But in all formulas, we use the SI unit. The SI unit of mass is kilograms, not grams. So M in this will be...
Divide it by 1,000.
Yeah.
Move
Yeah, whatever.
the decimal place. 1, 2, 3. 0.66.
Perfect. Okay. And what's the boiling temperature of the boiling point of water?
100.
Yep. So how much is the temperature changing by?
100.
No, try again.
What are you talking about? It's what?
How much is the temperature changing by?
Of what?
The water that we're boiling.
I don't know, Ron. It's 100.
We're starting at room temperature, 21 degrees. We're fucking boiling it to 100. How much is it changing? How much?
Just under 5. Just
What?
under 5. Change. Times 5.
No! How many degrees? How many degrees?
Oh.
Why?
Like you times it by 5-ish.
Why does your brain work like that?
What do you mean? That's logical. How much hotter are you getting it? 5 times hotter.
That is a baffling way for your brain to work.
Is it?
Yeah. How much hotter is it getting? 79 degrees hotter.
Yeah, 5 times-ish. All right, 79 degrees. Okay.
How much energy?
0.6679 now. Did I need to put that constant heat somewhere? Are you okay?
It's so hot.
Do I need to do anything with this constant heat number?
No, I told you that for fun.
Yeah, it's not kind.
What? Do you remember when we were doing formulas before?
No.
When we, we worked out how much gravitational potential energy and stuff had.
No. I don't remember that. That might be before I got my notepad. I don't know where the notes to that are. Totipotent? No, I don't have any notes on that.
So, do you honestly not know, how an equation works?
I'm not doing an equation.
This is an equation.
How is this an equation?
Delta E equals MC delta theta is an equation.
Yeah, I only understand the equals.
When things are just next to each other in an equation like that, you multiply them together.
You can't times a C by a triangle.
No, that's why they've all got numerical fucking values.
Okay. So, what was that? So I see. So the air is... Oh no, I should have had breakfast. That's why this is hard. So 0.66 times 79 times triangle times theta.
Not times triangle, because triangle means the change in. Triangle means the change in. Delta theta is one entity in this.
How the fuck are you supposed to know that? This is the problem, is that you're laughing at me like you don't know you've got to times them together, and then I times them all together, and you go, oh, except for if you're a billy goat, and then those don't times together, because those are the same and a partnership.
Yes, but Laura,
I know that.
You also can't blame me for not expecting you to have the brain equivalent of one of those pencils where you like push them in the end and then the other one falls out the other side. Like, we talked earlier about how delta means the change in, and then that entity is the change in the temperature. So, like...
So you need another sign then between the MC and the triangle, so that you know to stop timesing.
No, because if you could, like... You have idea object permanence. As soon as we stop talking about it, it's just gone. Because if you just know that delta means the change in, and it goes before the thing, and then change in energy, change in temperature, fine. If you just know that, and then sort of juggle two bits of information at once, then you're fine.
So the whole sum is just 0.66 times 79?
No, because the C's there as well.
I thought the C was the 79 bit.
No, delta theta, change in temperature. It went up by 79 degrees.
I am so confused about what we're doing then. The M
need
is
to
the 0.66.
M is the mass.
Yeah.
No, yeah, that's right.
What was the C?
The specific heat constant for water.
So we do need that?
Yes!
I asked if I needed the C, and you said...
I was taking the piss! Why would we not need it? Why would I have mentioned it? Why would it be there if we didn't need it?
I thought you were being serious when you said you told me.
Formulas don't come with supplementary information. It's not work this out and oh, by the way, the specific heat constant of water is 4,185.5. Isn't that a nice little tidbit? Work it out on your way. Why would it be like that?
Why is any of it like it is? I hate this so much. Okay.
Multiply the three fucking numbers together.
Stop shouting at me. Why are we multiplying the 3 together?
There are 3! M times C times delta theta.
You said we didn't times the triangle.
Not the triangle. Delta theta is one fucking entity.
Right, let's put that in a bracket then.
Okay, that works.
Okay. No, that doesn't work.
Yes, it does.
Because you do all the stuff in the bracket first. Even I know that.
But the stuff in the bracket is just the number 79.
Why don't we just write 79 then?
Because you need to... Because we can, we will. Write it down. Write down 79. Write it down. Write down 79.
Yeah, I've written it down loads of times, and every time it's been wrong. It was wrong when it was 0.6679. It was wrong when it was 0.66 times 79.
Yes, but you just need to... 0.66 times 79 times 4,185.5.
This is so stupid. I could have made tea by now. No, this is the worst science because nobody's got tea, nobody's happy, and this is utterly pointless. What a headache. Oh, 218,231.97.
Well done.
Is that right?
Yep, that is correct.
What does that mean?
That is how much energy it has taken to boil the water in our kettle for our cup of tea.
Joules?
In joules, yes.
Yes. Okay.
Nice, okay. So, the next thing that we're going to learn about is power.
Cool.
Power is defined as the rate at which energy is transferred to, or the rate at which work is done. Okay? So literally...
I really think that should be the end of the episode, Ron. I want to go and have a small cry.
No, you're fine. So literally, we just take the energy and then we divide it by the time that it took to do that. Okay? So for our kettle, let's say that it took 2.5 minutes to boil.
Oh, I'm getting a new kettle then. That is too long to wait. 218,231.97 divided by 2.5.
But we need...
87.
Wait. We need the SI unit for time, which is seconds.
Ugh. So... 150.
Yeah.
218,231.97 divided by, what did I say?
150.
1,000. Oh, I don't like numbers with commas in them. I don't know how to say them out loud. 1,454.8798. Energy.
Correct.
Powers.
Watts.
I don't know.
No, watts.
What's the power?
You know, like a 100 watt bulb.
Got ya.
Yeah.
Oh my god. There was a horrible moment there where you were just going, "What?" And I was like, "He wants a word," and I don't know what the word is going to be, and then I'm in trouble.
So our kettle is 1,454 watt kettle.
Great. Is that helpful? What does that do? Who cares about that? What?
So now we're going to talk about conservation and dissipation of energy.
Constipation?
Conservation.
Conservation.
And dissipation of energy. Energy can be transferred usefully, stored or dissipated, but it cannot be created or destroyed, okay?
Unless you're a god.
No, even them. No.
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 You don't know that.
Students should be able to describe with examples where there are energy transfers in a closed system, that there is no net change to the total energy. So a closed system is a theoretical thing that we use in physics to help us describe situations. It's kind of like when we talked about having point objects or frictionless surfaces and stuff like that. That's not... Are you painting your nails?
No. No, I'm putting moisturiser on with a glue spreader.
Are you all right?
It feels nice. And you
Okay.
can scrape it back off again, look. I'm listening. You can dissipate, conservate, and move, but...
What is a closed system?
Like CCTV. No? It's a science thing. Ron, it's a science experiment that you guys like. Is that what you said? You said something about a science thing.
It's a theoretical...
Don't crack your knuckles, it's threatening.
It's a theoretical thing that you use... Pay attention.
I am!
It's a theoretical thing that we use in physics to simplify things.
I bet it doesn't simplify anything. I bet it makes it all worse.
It's like having a frictionless surface. It can't exist in real life, but it simplifies the calculations we need to do. So a closed system just means that no energy is leaving or entering, okay? Now, we've had our cup of tea.
We haven't.
That we boiled. It was lovely. Now we're going to Tarr Steps with our family. So we've put some...
What a random example to use. 99% of the listeners will have just gone, what? Tarr Steps. So Tarr Steps is a place in Devon or Somerset. I don't know if it's over the border. It's a river, basically, with a little crossing, and you can go there and swim.
And it's got a Stone Age bridge.
That's true. A ford, too, hasn't it? Because you can drive through that bit of it.
Yeah, so we've had our cup of tea and we're going to Tarr Steps with our family. So we're going to put some apple and mango J2Os in a cool bag with some ice packs.
Well, we're not going with our family then, because there's no way they've sprung for J2Os for a picnic. We've got fruit shoots at best and we're fucking grateful.
What are the energy transfers going on inside the cool bag? For now, we are assuming that the cool bag is a closed system, okay?
Yeah, okay.
So we've got some room temperature J2Os, some chilly cold ice packs.
Yeah.
We're putting them into a cool bag together. Can you try and describe the energy transfers that are going on inside that cool bag?
I like that your questions are now like, can you describe? Can you try and describe? You don't have to get it right. You try some words?
Just give it a go.
So, triangle, E.
There will be, a change in energy of certain things, but not of the system itself, because we're talking about it as a closed system.
I don't know.
In the bag,
yeah.
what has the most energy?
The juice. It's got sugar
Yeah.
in it.
Let's talk temperatures, because we're cooling the J2Os down, aren't we? By putting them in the cool bag.
I think you'd have had them in the fridge anyway, to be honest.
No, they were out on the counter in the utility.
Then we fucked up because, like...
It's a long drive from Mum and Dad's to Tarr Steps.
Yeah.
They'll be fine.
But those packs are for maintaining a cold temperature, not chilling.
Yeah, we fucked it. It's all okay. We've got ice packs coming out. The yin yang is all right.
Okay. What do you want me to say? I don't understand. What? Everybody knows it's going cold, isn't it? In the chiller bag.
So describe the energy transfer. Where is the heat energy going?
Whichever direction the J2Os are in.
But they're not going to. It's not going towards the J2O.
Yeah,
is
the
it?
cold energy is getting in the J2Os, and the heat energy is
Okay, cool.
getting
Right.
in the cool.
So there we go. We've dredged up something from the swamp of your mind. There's no such thing as cold energy. Cold is the lack of heat. So where is the energy flowing to?
What do you mean? What?
There's
Left.
heat energy.
Left.
There's heat energy in the J2O.
Okay.
The J2O is cooling down. So do you accept that heat energy is leaving the J2O?
If that's what it takes to finish this, fine. No, that sounds stupid. Cold is getting in the J2O. Otherwise, you're putting J2Os in to heat the ice packs up. And that isn't what we're talking about.
That is exactly what we're talking about.
Oh, that just feels so cruel to the ice packs then. They think that they've got this job to do, but actually, they're not doing anything. They're just having stuff done to them. They're like sacrifices.
Yeah, they're taking in heat energy, not only from the J2Os, but also from the air inside the cool bag. They'll take in energy from these.
Oh. Well, no, I just feel sad for them.
Students should be able to describe with examples how in all system changes energy is dissipated so that it is stored in less useful ways. This energy is often described as being wasted. So, for example, if we have a car that's driving along, the car that's taking us to Tarr Steps, that engine is burning fuel to move it along, but then it's also creating a lot of heat. The engine gets hot, right? So that heat energy is waste energy,
Yeah.
right?
Yeah. Yeah.
You know, I know when you're doing a fake yeah.
Yeah. Yeah. Yeah. Mm-hmm. Yes, Ron. Yes.
So, let's think about our cool bag in the real world. Where is the waste energy? Or where's the energy coming in?
The zip?
Through the bag, yeah.
Yeah. Is that okay? What else do you want?
Right, let's rattle this off. How could we improve our cool bag?
Nice colourful one is always good, so you know which is yours. Quite unique. I don't like the solid ones that when you're trying to walk along with them, they bash your knees. I like a soft cool bag. Easier to pack in the car as well, because you can, like, put stuff around. Do you remember that one that Mum and Dad had that you could plug into the car?
That's right, Laura. More insulation would fix our cool bag. Or maybe some bigger or better ice packs. Now, Laura, do you... the thermal conductivity of the material we use for the insulation, do you think that we want it to be very thermally conductive or not very thermally conductive?
Not conductive. I wouldn't want a copper cool bag.
Exactly. Well done, Laura.
I know about copper because of saucepans.
Do you, what part of this system that we're describing, do you think we would want something with high thermal conductivity? That's right, Laura.
The ice
packs. The
packs.
ice packs and the J2Os.
Give me a minute to have a think, you old goat.
Fiddling with your AirPods.
I was thinking, it's not AirPods. I don't have AirPods. I would have lost them instantly. It's just this plug.
Oh, it is just a plug.
I concentrate better when I'm fiddling with things. That's
it. That's the end.
I said it.
Yeah, well done. I said well done many times.
Don't say well done like you're not happy with me.
I'm happy with you.
You are so much like Dad. It is just sad.
So that's the end of the lesson.
Oh, God. And we've just not learned anything. It was all pointless. It's so stupid. We haven't got any tea. We haven't been on a day out. We've got nothing. All I know is that the kettle is like 1,454 watts. I don't even know what the point of that is.
So you know how much power it's using?
Who cares? I'll know when I get my electricity bill.
Well, yeah, but you might care after what Rishi Sunak's done to energy bills in the UK.
Then what am I supposed to do about that?
So if you saw something that had like a lower wattage, you'd go, oh, that's using less energy.
Yeah, but maybe it takes longer to make my tea.
Yeah, so like for tea kettles, maybe not the best, but like light bulbs.
But maybe they put out less light.
Well, they probably wouldn't, otherwise that's a shit light bulb.
So if I've got a lower wattage light bulb...
It's using less energy.
But how do I know that it's putting out the same amount of light?
With your fucking eyes, I should think.
Yeah, but in the shop, when I'm wandering around B&Q and looking at the shelves, I don't know that, do I?
Well, then go back and put it in, and then if it's still dark after you turn it on,
well,
go back to B&Q. Go back to B&Q.
What,
say, I'm sorry.
Hello, here's a light bulb out of its packet.
This light bulb doesn't work. It's still dark in my house after I plug this light bulb in. Another one, please.
Just because you're raking in your Brussels money and you've got enough money to buy 3 light bulbs and return them all, this was useless. Thanks for wasting my day teaching me this garbage. I'll see you in a week for the quiz. So, quiz time. A physics quiz. I can't see how this can possibly go wrong.
Why on earth did you start doing that while I was taking a slow drink of water?
I'd just like to catch you out so people know that you're not professional. And it's been 2 weeks, because we had last week off, didn't we? So it's been forever since we even did physics.
Yeah.
Oh, God. I'm looking at my notes from last week and they make no bloody sense. There's just a load of triangles.
Well, that brings us on to question number 1.
Oh, shit.
Can you please write down the formula delta E equals MC delta theta?
It's still written down in my notes from last time, so does that count?
Yeah, that's wonderful. It's just you need that formula to complete the question.
Oh, shit. Okay, yeah. So triangle big E equals small MC triangle Jupiter. Or Saturn, really, Saturn. Isn't it?
Yeah, much more. Okay, so...
Is planets a science?
Yes, astronomy. That comes under physics, usually.
Oh, will we do that? That would spice up physics if we did a load of planet stuff.
Yeah, but I think we just see the seesaw of interest tip the other way because I won't give a shit.
Oh, okay. All right, right.
You know how you're like, this stuff's too small. Why do we care about it? I have the same thing, but that stuff's well far away.
I
Why
feel
do we
the
give a shit about
same.
it?
Space is too big and too far away, too cold. Stop poking it, leave it alone. That's how I feel about space.
Bigness, I think, is a good thing, and the bigness of the sun, I'm like, whoa, so big. And it's not that far away, but like Jupiter, other galaxies, black holes, couldn't care less, really.
No, too big, too far away, too cold. That's how I feel.
Anyway, I put a 1.5 litre bottle of room temperature water into a freezer to freeze it.
Oh
so
dear,
that
I've
I
got
can
such a
use it.
sinking feeling. You put a what? You did what?
1.5 litre bottle of room temperature water into a freezer
Yeah.
to freeze it so that I can make an ice pack because I'm going to a mainstream day out tomorrow.
Wonderful.
Room temperature is 21 degrees.
Okay.
How much energy leaves the bottle when we freeze it?
What are you fiddling with? It's very annoying. Stop fiddling.
I'm not fiddling, I'm Googling something.
Oh my god, and I've got to work that out with triangles. Oh lord, none
Room
of the...
temperature is 21 degrees.
Yeah, I've written that down. Oh lord. What is happening? Oh, Ron, I've got no idea. Why is that
Why
saying
don't you try and
66? So
break down
I am.
what the formula is.
I am. So 1.5 litres. Is that at the SR unit, Ron? What's the
Litres?
SR unit of water?
Very close. SI unit.
SR! Damn it! I thought I was being well clever remembering to ask that.
No,
What is it?
because we need M. M is mass, isn't it?
Yeah?
So litre is a measure of
Water.
volume.
Oh, God.
For
So
our
we've got to change
purposes-
it into grams.
Yeah, for our purposes, let's just say 1 litre of water weighs 1 kilogram of water.
So I've got 1.5 kilograms of water.
Yeah, which is actually in the SI unit. I don't know why I was being so mysterious.
Let's just say, it's roughly, oh, how did I trip over the right answer? But kilograms isn't the SI unit, is it?
Yeah.
Oh, okay. So that's the mass. And then we multiply. Why have I got McDeath written down? Why are none of my notes helpful? How can you make a page full of notes and none of it mean anything?
So what do we think C is?
Well, I've written down that C is the heat constant.
C is the heat constant.
Can I have a point
C
for that?
stands for constant.
Okay.
So the specific heat constant of water, write this down, is 4,182.
Oh, I've got that written down.
Yes, we did this last week.
Oh my god, I got no idea what I'm doing. So it's 1.5 times 4185.5.
Yep.
Yep. Okay, well, let's do that.
Don't stall by doing half the sum.
Okay, well, because next up comes the triangle and I can't remember. Oh, I'm getting a phone call.
Ask them.
I can't answer that phone call right now. I'm doing important science. Oh my God, I want to answer that phone call
Who
so
is
badly.
it?
I don't know, actually.
Answer it and ask them. Tell them you're doing a quiz.
Excuse me. Doing a really unhelpful quiz. 6,278.25. Now, in my notes from yesterday, I've multiplied that by 79. I can only assume... What am I trying to do to this water? I'm trying to freeze it.
Yeah. Well, we're working out how much energy it's taking to freeze it.
All right. The triangle is the change.
Yeah.
So I'm going minus 21. So 6,278.25 minus times minus 21.
Not minus 21, because the change is still 21 degrees.
Oh, I see. Yeah. So times
yeah.
21. Yeah. Oh, God. And then what does Saturn do?
No, so the triangle,
Yeah.
the change, refers to theta.
Oh, okay. So it's
so
just...
theta is the temperature, so it's just saying the change in temperature.
So times 21. So 131,843.25.
Correct answer.
Joules.
Well done. Joules indeed.
Oh, it was the guy that's coming to repair my sofa tomorrow. That's who was calling me.
Definitely think you should have asked him.
I'll ask him tomorrow.
Okay. 1 mark for question 1.
So just to clarify then, so you calculate the energy required to change water by the mass multiplied by the heat constant times by the number of degrees it's got to change.
Yeah, and not just water, but obviously the heat constant's going to change. So, like,
Well, how the hell do you find out the heat constant?
Well, rearrange the sum. If you divided the amount of energy something took by the mass and the amount of the...
But then how do you find out the energy?
You could put a known amount of energy into it.
Oh, clever. This is why you're a scientist. Yeah.
But not just water. It's like you, Laura, you would have a specific heat constant.
No, I fluctuate.
Yeah, exactly. You fluctuate, but at a regular pace. Right, okay, question number 2. You got 1 mark for that. Ding, ding.
Ding, ding.
I put that water bottle into a cool bag to cool down 8 Asda own brand refreshing juice drinks. Please describe the energy transfers within the bag.
Say all of that again, because I was looking at my cup of tea and thinking about the energy in it. What did you say?
That's the first step. Start thinking about the minutiae of everything. I said, I put that water bottle into a cool bag to cool down 8 Asda own brand refreshing juice drinks. Please describe the energy transfers within the bag.
Consensual.
Where's the energy coming from and where's it going to?
It's coming from the... Every fibre of my body wants to say the sun, and I know it isn't right. But so don't listen to that bit. Let me think more. There's only 2 things in the bag. So, is it the cold thing or the... I think it's not... The juice drinks. It's the juice drinks are hot. So they have extra energy. And they are going in... The energy's going into the cold water bottle.
Yes, absolutely. Heat energy is flowing from the juice drinks, the own brand refreshing juice drinks, into the frozen water bottle.
Do you miss Asda now you live in Brussels? You talk about it quite a lot.
Do I?
I feel like it comes up.
Oh, I had to change all of this stuff because last episode you mocked me for mentioning Tarr Steps because that's not that's not something everyone knows about. And then apparently, J2O's too fancy, which is why I've made these changes. That was like question 2 was something that for the listener we covered maybe 20 minutes ago, just with different things. Okay, yes, another mark for question 2.
I'm killing this quiz.
Final question, because it is a physics quiz, so we never cover that much. What is a closed system?
Oh, it's like a science vacuum for thinking about hypothetical stuff in.
Yeah, and what's the sort of assumption that we make in a...
No wind. No.
Come on.
I really thought it was wind. No anything except what we're talking about.
Come on, we were so close to 3 for 3, and then it is a science theoretical vacuum thing, but
Yeah.
but what? It's closed.
Yeah.
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 So
It's closed. Is that what you want me to say back? Is this one of those ones where I just have to say it's a system that's closed?
no, but maybe think about the definition of the word closed.
Yeah, there's nothing going in it. That we're just, it is what we're talking about and not extra stuff.
Say that like a normal person.
Like, what do you mean? It's a system that is closed and it has no wind in it. And
Forget wind.
it's got no, like, friction and doors.
No.
It's got no, like...
No, you're further away now, colder.
It's closed. It's got no... Down? It's got no, like, stuff. It's got no, it's like a vivarium or something, you know? Like, it's a closed system.
I don't think I can give it.
Why not? You know I know it.
Well, then say it.
I have. In every conceivable way, I've said it.
In no physics textbook in the world does it say it's a closed system, you know. There's no wind. It's like a vivarium.
All right. Hello, sirs and professors. This is a closed system. It only holds the science that we're currently doing, and no other science can get in or out of it to mess with the experiment.
You basically just said it then. Replace the word science. You said no science can get in or out of it.
Yeah.
Yeah.
No people?
No. I don't remember last week a person climbing in the callback.
No extra juice or stuff?
Yes. No matter can come in and out.
Yeah.
And...
That's good. What do you want me to say?
no energy can leave or enter the system.
That's implied.
Is it?
Yes!
Half a mark.
Oh, piss off. A whole mark.
Absolutely half a mark. So 2.5 marks.
2.5 out of 3. My physics personal best.
Well done, Laura. 2.5 out of 3.
Yeah. Although, according to Carol's statistics, I am better at physics than anything else. So I think, I was like, oh, it's my personal best, but I don't know if it was. How does statistics work? That's quite high, isn't it?
By Kevin's metrics, you're actually very even across the board.
Wait, I've missed what's happening with Kevin's metrics. What's happening with Kevin's metrics?
So I think, if I'm remembering correctly, Carol was weighting each mark individually the same, whereas Kevin weighted each quiz individually the same. And if you do it by Kevin's way, it was like 70% for all of them, and then by Carol's it varies.
Well, I don't know what that means, but good. Well done. I am a genius. I think that's what we're learning over the thing. So thank you very much, everyone, for listening and for sharing. I don't know if it's cool to say this, but we've seen a 45% increase in listeners this week, which is just huge. And it's down to you guys being so fun and generous and kind in sharing what we're doing. Obviously, like, we're a brand new podcast, and yeah, I've got a bit of a platform which has helped us launch it, but it's still, the numbers of people that listen to your stuff is not sort of equivalent to how many followers you might have on Twitter or stuff like that. But you guys engaging and getting involved or rating or just retweeting when episodes drop and stuff is absolutely massive. And it's really been like a real turning moment this week of like, oh, this might actually catch on and sort of become a thing. So thank you so much. That is super down to you. And next week, and also I did want to say, I know we do a lot of like reading out the interactions from people on social media. If you're just listening quietly, we love you too. We totally get that a lot of listeners like listen in the car and never make contact with the people that they love. That's me and most of the podcasts I listen to. So hello to you too. We do love you.
Yeah, and even if you do want to get in touch, but you don't want to do it on social media because you've decided not to sell your data to everyone that might want to get it, you can get in touch via email as well. We've never had an email.
But we are on Gmail, so I'm sure that is still selling your data.
No, it's not the same.
Okay, cool. Well, yeah, either way, silent lurkers, noisy little lovebirds, we love all of you. Thank you very much for listening. Next week we are back. It'll be our 10th episode, and we're back to biology, and it's very rainy in Brussels next week. So if you're missing the rain in parched, scorched England, next week you can listen to some rain.
Class dismissed.
Oh, you did it.
First time.
Woo!